In this recording, we're going to learn about the inverse sine and cosine functions. So, back when we talked about functions, you learned that a function that is not one-to-one has an inverse that is not a function. Therefore, these functions that we're going to look at, the sine and cosine functions, must have a restricted domain. Let's see some pictures, because I know you're kind of wondering, well, what's that saying right there? So let's look at a graph of sine of x. Now the nice thing about this colored fancy version of the TI-84 Plus is that we have different colors. We're going to see this very distinctly. I'm going to graph sine, and we hit zoom 7. There's your graph. You can see it is not a one-to-one function. There are several values of sine, for example, that have a value of 0. Several x values that produce a sine value of 0. So let's look at the inverse. And what you can do on your calculator is you can hit second draw, and you might not have even known this is a feature. Then you can go all the way down to choice 8, which is draw inv. And it needs to know what do you want to draw an inverse of. And because I've got it in y2, there's a reason I've got it in y2, because I want it to be a different color. It's going to draw my inverse in blue, in other words. And then I hit second trace, alpha trace to get to the vars menu, and I want y2. So even if you're not doing this on your own calculator, no problem. The point is that you see this. Okay, I've got my sine function in red, which is not one-to-one, but is a function. Its inverse, which means we're going to switch the x and y of all those points, is clearly not a function, right? There are more than one y value for a particular x, like x of 0. Just like we said, sine has more than one angle that gives us a sine value of 0. So this is a problem. So if we want it to be an inverse sine function, what we have to do is restrict the domain a little bit, such that the red graph is a function. And what we're going to do on this, if I can take a screenshot, I'm going to restrict this red function to just this portion right here. All right, up until it stops becoming one-to-one. If I restrict the sine graph just to that portion, then the inverse of that will be a function, because the original graph, the black graph that I drew here, is one-to-one. So let's come back to our sheet. And by the way, if you don't have this sheet, you can get this in Schoology in the folder for this unit. Okay, so what we said is, for the sine function to be a function, we must restrict its domain between negative pi over 2 and pi over 2, right? Negative pi over 2 to pi over 2. Okay, and the inverse, the notation we're going to use, remember we use like f with a -1 superscript. We're going to use inverse sine of x, and that's a button on your calculator. You can see right here in blue to find the inverse. You're familiar with that. And then we can also say arc sine, which is said to be the angle whose sine is whatever. Okay, so it's always to find an angle. These are synonyms. Okay, arc sine and inverse sine are saying the same thing. All right, for cosine, well, let's look at our cosine graph. I'm going to go here and do a clear draw. So that's just under the draw menu. We go back here and change this to be cosine of x. Graph that. There's your cosine graph. Well, I want to restrict this in such a way that it is a one-to-one function. And so I'm going to go from 0 down to pi. And after pi, it starts not becoming one-to-one anymore. So that's what we're talking about here. We're going to restrict cosine from 0 to pi. Its notation is very similar. Arc cosine, inverse cosine. Right? And these graphs, as we saw, are symmetric about the line y equals x with any inverse. That would be true. So What will we ask you to do for these inverse sines or arc sines? Well, we're going to use our calculator. I'm going to change the directions here a little bit. We're going to go directly into, we want the radian measure, but we're going to directly go into radian mode. So let's scratch this, put the mode in radians. And we just get the value to the nearest hundredth. Okay, so let's act out a couple of these. If you have a calculator, I'll show you how to do it. If you have Desmos, I'll show you how to do that as well. So on your calculator, you're very familiar with this. Be in the home screen. If it says arc sine, you're just going to see it as inverse sine because they're synonymous, right? So inverse sine, let's make sure I'm in the right mode. I am. I can see on this fancy calculator right here in radian mode. Great. So I'm going to go inverse sine of 0, and it's going to tell me the angle that has a sine of 0. If I want to do inverse sine of 1, or arc sine of 1, I'm going to do the same thing, but I'm going to use inverse sine. Okay, so arc sine, inverse sine. So it says 1.57, which is half of a pi. Let's see what that looks like in the Desmos world. So over here in Desmos, you're going to go to desmos.com. And instead of hitting start graphing, because I'm not looking for a graph right now, let's hit scientific down here. We want to be in radian mode, so you can swap that right here on this switch button. And we see sine, but we don't see anything for inverse sine. So what you want to do is hit the func menu, hit inverse sine of 1, for example, and the answer shows up right here, 1.57. So it's super easy to use in Desmos. So no excuses if you don't have a graphing calculator, no problem. We can get this work done. Okay? So confirm a few of these. Just take your calculator and confirm that inverse sine, or arc sine in this case, arc sine, work out these. And then when you get to this final one, this is saying, take the sine of the angle, whatever that angle is, that happens to have an inverse sine of 0.2345. Okay, so find the angle first, because we have to work from the inside out. Find the angle first, and then take the sine of that angle. So work that one out as well. Play the recording when you're ready. Okay, so hopefully you did all that. I'll just model for you the last one, because that one's slightly different. So we're going to find the sine of the inverse sine of the ratio 0.2345. Close it off. Okay, so we're doing a composition of functions here. I'm going to close off another parenthesis to match every parenthesis. Wow, that's weird. It came out 0.2345. Well, all that's saying, right, is that when you take the sine of the inverse sine, they undo each other. It's like multiplying by 4 and then dividing by 4 again. You should be back to where you started, right? Because they're inverse functions. We've talked about this often with your log and your 10 to the x, your inverse functions here of your exponentials, also your square and square root. Well, sine and inverse sine are on the same button as well, right? So no shock there. We have inverses for all these operations. We just need to restrict the domain of these such that inverse sine is going to produce a function, not just a relation. Okay. So finally, what if it's a little more complicated? What if I don't want to just find the sine of the arc sine so that they're going to completely undo each other? Instead, I want to do the sine of the inverse cosine, which is a different function. Well, no problem. I can still do what I do. I can find the angle that has a cosine of root 3 over 4. Once I've done that, then I can produce the sine. We've done similar work to this in our unit 12. We just didn't write it this way. We might say, given that the cosine is root 3 over 4, I'll write out something like that down at the bottom. And I'd have to specify the angle's quadrant. And again, the quadrant for cosine would have to be restricted between 0 and pi. So I know if it's positive, it's in quadrant 1. So again, given that information, and theta's in quadrant 1, find sine of theta. This is basically saying that same thing right here, but very concisely. So how would we find the angle that has a cosine of root 3 over 4? Well, we have to first set up a reference triangle. Remember, cosine is x over r, so you could set that up. Do some Pythagorizing to find out the y value of root 13. Okay. And now the sine value, your opposite over your hypotenuse, or your y over r, is root 13 over 4. Okay. So shooting over here, and I can confirm that again. I can confirm that with my calculator, confirm that that is correct. It's just that my calculator is not going to give me the exact value. It's going to give me a decimal approximation. Okay. So I could put this whole thing in and find it and then confirm that it is equal to root 13 over 4. Let's shoot over here. So on the number 2, what we're saying is the arc sine, the angle that has a sine of negative 2/7. So you might wonder, well, what quadrant do I put it in? Well, think back up here. Sine is restricted to negative pi over 2 to pi over 2. That's how we're restricting it. So remember, negative means go down this way. Positive means go this way. So I'm restricted to this arc here. That's why we talk about arc sine, right? No coincidence there. So if it's a negative, that means it has to be down in the 4th quadrant. It could not be in the 2nd quadrant, or the 1st quadrant, right? Right, so we sketch it out. Negative 2 over 7, that's our y over r. Pythagorean theorem to find the x. And now our cosine is the x over r, and of course that's positive. We could check this with a calculator. All right, flipping to the back, we've already done some pre-work here talking about the graphs of inverse sine and the graphs of regular sine and cosine. Well, if I can just imagine here, this is the sine function. I tried to illustrate this earlier, but this is the sine function. Maybe you want to just take your pencil and just make a little dotted graph going on. That one's pretty poor, but I tried my best. That one's a little better. So that just gives us a sense of the cyclical, the periodic nature of sine, but we're restricting it in such a way so that sine is 1-to-1. Therefore, when we do the inverse sine, we get a function. Let's see what that function looks like in Desmos first, and then we'll use our graphing calculator. So go back a level, hit Start Graphing. Again, functions. I'm going to make this a little bigger. Okay, now you can see over here. So I'm going to hit Functions, Inverse Sine of x. And you can see it is a function. It does not continue to kind of serpentine up the y-axis like we saw in the graphing calculator. That is a function of sine of x. You can do the same thing with cosine x. Okay, so clear that out. You just replace that whole thing with cosine inverse, right? And you can see it's restricted in such a way that it's an inverse, that the inverse is a function. All right. Notice the range of cosine is between 0 and pi. You can see it's about 3.14 right there, right? 0 to pi. Let's just do a quick demo of what that looks like in the graphing calculator. So second inverse sine of x, hit zoom 7. There's our graph. You can see it extends. Okay, this would be the domain of inverse sine between -1 and 1, and the range goes from about -1.57, right, because this is 1, it's a little bit beyond there, to 1.57. All right. Cool. So what do we ask you to do with that? Well, be familiar with those two graphs and their domain and range values. They're sketched out here. And what about transformations? Well, just think about what this would be. Don't peek anywhere down here. Just cover that. Oh, I'm going to do a little cover here. Just cover as I'm showing here. Cover with your hand anything below those graphs. Maybe right below those functions. And just say, okay, what would the 2 do to any function? What would the -1 outside the function do? Over here, what would a negative sign do? What would a +1 inside the function do? The whole point here is your rules for transformations still apply. Consider that. Right over here in the margin what you think's happening. and then play the recording when you're ready. Okay, so hopefully you considered that and you realized, hey, it's going to stretch vertically by a scale factor of 2. You're going to shift down by 1. Over here, you're going to reflect over the x-axis because of that negative outside. And inside, remember we have to concentrate on the +1 inside. We're going left. Okay. All right, and so finally, how could we solve something like this complicated looking equation? Well, we're going to make a graph. So grab your calculator or your Desmos, whatever you've got, and let's go into the y equals. Desmos is actually easier. You can put this right in there. So, and it's going to jump right to the solution. So I'm going to go inverse sine. Okay. Once you've made that graph, Desmos just automatically shows you where the 0 is, 0.89, as it says in the note sheet. If I'm in my graphing calculator, same thing, but it's actually a tiny bit more work. Okay, and if you recall, we're going to look for the zeros. So we'll make our graph, and we're going to look for the zeros of the graph right about there. So we'll go to second calc, choice 2, left bound, good, right bound, slide it as far as you can there. It's kind of off the chart a little bit. And your guess. And it found us the 0 at -0.89. Thanks for watching.